I'd like to work out page 42, number 2, which is read the sum from k equals 7 to 984 of 13k minus 7. And what it means is to get the first term of the series. The first term of the series is not 7. 7 is the first number you plug in for k. And when you do that, you would multiply that 13 times 7, which is 91. And then you would subtract 7, which is 84. Or subtract 91. Ha! 91 minus 7, yeah, another little error there, is 84. So that's what you get for the first term. Boom. And let me make that visible. Now the second number is going to be what you get when you replace k with 8. 13 times 8 minus 7. And what's that? Well, that's going to be 104 minus 7 is 97. To get the third term, we've already plugged in 7 and 8. Now we plug in 9. When you plug in 9, you get 13 times 9 minus 7, which is 117 minus 7, which is 110. When you plug in to get a sub 4, notice a sub 4 is the fourth term, and the terms start with k equals 7, and then 8, and then 9, and now 10. So 13 times 10 is 130, minus 7 is 121. Now, we don't want to write out all of these because it would take a long time and not be very exciting. However, I do need to know the value of the last term in order to use the formula. And the last term of the series, again, is not 984. The last term of the series is what you get when you replace k with the upper limit of 984. So that's going to be a calculation that I hope you use your calculator to figure out. 13 times 984, because that's what that is, minus 7. And I will send this video link to you so that you can verify that if you want. Now, n is the number of numbers. And when you have sigma, it's really straightforward. You don't have to do a lot of calculation. It's just going to be the upper limit minus the lower limit plus 1. 984 minus 7 plus 1 is 978. So now that we have the first term, which is 84, that's what you get when you plug in 7, and the last term, which is 12,785, now we can use our cute little formula from page 40, I believe. And it's going to be the first number, 84, plus the last number, not 7 and 84, but what you get when you plug in 7 is 84. What you get when you plug in 984 is 12,785. And that means 12,869 times 978 divided by 2. This is going to be, I hope you find this to be rather incredible. We just added up 978 numbers, and the total is 6,292,941. I think that's quite remarkable. I'm also going to show you something else. The something else is going to be using the internet to get this same answer. Really? Yes. Now, you may notice on page 42 that right underneath that, I have typed in sum from k equals 7 to 984 of 13k minus 7, and that can be worked out if you just put that in this website called Wolfram Alpha. And watch how long it takes or how short it takes to do this. Boom. And it tells you the input is interpreted to mean the sum from k equals 7 to 984 of 13k minus 7 is, and by golly, that was painless. Now, here is the wonderful news. You will be allowed to use Wolfram Alpha on the actual test to get the answer, which means I want you to become really, really familiar with it beforehand. Furthermore, on page 42, I just worked problem 2. There are some interesting problems, I suppose. And I also have included the code that you type into Wolfram Alpha. However, this is a little bit tricky. The only way that I know what this code is for number 3, notice there's no sigma here, really. So how do I know that code? And here's the short answer. I made up the problem. However, if I give you a problem like this on the test, I'm not going to tell you what the code is. It's going to look like that. Oh, so how do I figure out what that is? Well, here's the short answer. If you look at 9 plus 6 plus 6 plus 6 plus 6, it's going to be arithmetic. Well, so you could use, and it would be a really good idea to get good at this, you could use this formula which says if capital A sub n is the sum of the first n terms, here it is. It's the first number, A sub 1, the first number in the series. Like here it was 3, and 346 was the last number, times the number of numbers divided by 2. Okay. The good news is you can actually go to Wolfram Alpha and either just key it in or copy and paste it, which I found you can do. And it's going to tell you, oh, there it is again. It tells you what this looks like. However, if it gives you, if you get this without sigma and without the code, like here, number 4, I put the code in there because it's my problem. You can also go to Wolfram Alpha and you can plug in those numbers and either hit the equal sign, click on the equal sign, or hit the enter key, and it will tell you, not only will it give you the answer of 9 plus 15 plus 21, yada, 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 it will tell you the sigma form of it, or one of the sigma form. You can write this in many different ways using sigma just by adjusting the 3 to be something entirely different. So that's 2,916,585. And it's important to look at what the answers. There it is, 2,916,585. So what I want you to do for the rest of the class period is work some problems on page 42, but to really do the most good, get really good at using Wolfram Alpha. There's a link to it right there on page 42. You can click on that and input your code. Make sure that when you do that, the input interpretation comes up to be equivalent to what we have on the actual problem. Notice that when you just list a string of numbers, you just put plus dot dot dot. Don't put any spaces between the pluses and the dot dot dots. You will get Wolfram Alpha's interpretation, and Wolfram will also give you the sigma notation involved, which is really rather cool. This is a powerful, powerful website and a powerful piece of mathematics. But I want you to learn how to use it on Wolfram Alpha because there's an application I'm going to introduce to y'all in November about how you can use Wolfram Alpha to work a problem that is kind of important to some people in life. It has to do with saving money for 18 years to send your kid to college. How much do I need to save every year? Okie dokie. And that is, let's see, let me turn this on.